Greetings. Thank you for joining us today for this Mirantis webinar on virtualization migration, a path to a place after VMware. Would like to introduce myself. My name is Michael Ward, and I will be speaking to you today on a number of the topics regarding this transition of virtualization workloads from VMware to other options. I've been involved in the building and definition of data center products and solutions for over 20 years across the networking, compute, and storage aspects of the data center environment. Today I have with me Heiko Kramer, who is a senior workload subject matter expert architect for Mirantis. And Heiko, why don't you introduce yourself?
Yes, thank you, Mike. Hi, guys. I'm Heiko Kremer. I'm working, I don't know, around 5 years with Mirantis, and in the overall architecture world, I'm working since more than 12 years. I started around 2011 with OpenStack Diablo at this time, and actually, well, jumped through all the layers from Linux operating over OpenStack to PaaS systems and workload delivery and resiliency. And today I'm presenting to you the technical aspects, how we are doing this, and I hope you will enjoy.
Great, Wigan. Thanks for joining us again today. So today we'll cover a number of topics. First, we'll discuss a variety of alternatives to VMware for your virtualization workloads. Then we'll move in transition to talking about key factors to consider when planning a migration. We'll go through an overview of the workload migration phases and also discuss some migration challenges and solutions to those challenges as you face these virtualization migration. So if we look at the virtualization landscape, quite a number of things have been changing in the market around this over the recent years. The first is the market is clearly trending away from fully private infrastructure towards enterprise and public clouds. There's a definite move from hosting all of your infrastructure on-prem to leveraging either colo locations or certainly the various public cloud providers to host, whether that be your virtualization workloads or an increasing trend towards containerization and cloud native offerings. Certainly, very recently, back in May of this year, Broadcom announced the intent to acquire VMware. And this has created a bit of a disruption, if you will, in the virtualization industry in terms of a lot of customers now uh, looking at options or just having concerns over what the future holds if they're a VMware customer and what that means to them and what options they need to be considering. So to that respect, many of them are asking, what's my backup plan? What's my plan B? Should things pan out in such a way that they're not comfortable with the future of VMware and their relationship with VMware for their virtualization offerings? So certainly a key factor that needs to be considered. We also maybe need to ask the question, is virtualization still relevant in today's time? The industry has been rapidly moving to containers and cloud native based architectures. And so you oftentimes need to ask yourself, if you're considering a transition to another virtualization platform, are your virtualization workloads still relevant? Why should you migrate versus refactor those applications towards cloud native? And I think the reality is, for many customers, there are legacy workloads and applications that they have in place, which perhaps just do not make sense to refactor into a cloud native architecture. It may be a legacy application that has somewhat of a limited lifespan going forward, and just the ROI to rebuild, refactor that application into cloud native just perhaps doesn't pay off, and there's a need to just continue forward with it as is. It works and serves the need, and makes sense just to leave as is. So therefore, there's certainly still a place for virtualization workloads in the industry, and it's just kind of taking aside or sitting aside containerization and cloud native applications, but certainly still has an important place. So you certainly have choices for your virtualization workloads. One option is to move your virtualization workloads into the public cloud, to move it to the likes of Amazon AWS, Google Cloud, or Microsoft Azure. This gives you the benefit of on-demand services and scalability and resiliency offered by public cloud providers. But the downside of that is the fact that once you have moved your applications, your virtualization workloads to a particular cloud provider, you've effectively moved from one locked in environment to another. You're restricted to the infrastructure and the APIs provided by that particular cloud provider, and you lose the ability to easily move to other platforms. And this is something we've heard time and time again from our customers is that they're looking for choice. As the landscape continues to emerge and evolve and change, they want to make sure that they're in a position that they can adapt and move and be nimble as necessary to adjust to changing environments. So a key solution that can help solve that for them is OpenStack. OpenStack is a open source uh, virtualization infrastructure environment, which can address the concerns of the lock-in aspect because it is fundamentally built around an open source offering. Um, it gives you the ability to leverage your on-prem infrastructure, your existing infrastructure, or you have the ability to host it in your choice of cloud. And then again, very importantly, you're not locked into any particular vendor because it is built from a collection of open source projects that are also well supported by commercial entities around that. So as we look at OpenStack solutions to move from the likes of VMware over into alternative offerings for your virtualization workloads and into the world of OpenStack, Mirantis offers Mirantis OpenStack for Kubernetes, which really couples the best of OpenStack and Kubernetes to provide you with an enhanced virtualization environment. Gives you the ability to simplify your deployment with pre-integrated, validated distributions, which is a very important aspect when working with an open source based offering. We've validated in all the various components that come together to make up the OpenStack offering, have validated those, and we test and stand behind and support those individual components as a validated release. The broader OpenStack offering can be managed through a single pane of glass from an offering called Mirantis Container Cloud. And this gives you the ability to have a single view into your overall OpenStack infrastructure, as well as potentially a Kubernetes-based container infrastructure if you're starting to migrate towards cloud native. And then the benefit of Kubernetes that enhances OpenStack gives you enhanced resiliency and availability of your OpenStack infrastructure, providing you with zero downtime, non-disruptive updates, fully automated day two operations, and then full stack management from bare metal through the operating system and all the various necessary components. So let's begin to talk about the transition from VMware virtualization infrastructure over into OpenStack. Let's talk about the topics now of what do we need to plan for? What factors must we consider for the migration? What risk might we encounter? And what are the unexpected benefits we gain as our journey is complete? And with this, I'm going to turn it over to Heiko to sort of dive into these topics and these challenges and give us the view forward of what we need to be thinking about.
Hi guys. So yeah, I will describe you first what we are trying to solve today. For sure, we are here that I show you a bit and talk a bit about moving workloads around, right? And in particular today, moving workloads from VMware to OpenStack. Usually, a workload owner and or the team itself don't have enough resources or time for the actual migration. For sure, this heavily depends, and there I'm speaking actually about point 4 here. This heavily depends if automation is in place or not, right? So if automation is in place, for sure, this time for to migrate something from A to B, and well, it depends for sure which source and target environment it is, but it will definitely reduce the time of migration. But nevertheless, there are several complications, especially because every workload is unique, right? So in terms of a provider who just see the workload as a virtual machine or just a bare metal node or whatever, it's pretty hard to say, okay, I want to migrate a workload from my VMware environment to an OpenStack environment. What do I have to do there? Because and that actually for every single customer. Therefore, and I will talk later a bit more about it. Therefore, you need to define a very detailed process for it. Um, and actually, the last point, what is also needs to take into account is that every single service relies on every single workload relies on maybe external services or also internal services, right? It can be a database as a service offered by another department, or it could be just a database which is deployed in your cluster or in your folder, who needs to be migrated, but you need to take into account the migration order. So let's first of all take a look which migration methods we actually have, right? So there's typically a simple lift and shift approach, which means it's actually a one-to-one copy, right? That you try to move all entities from the source to the environment like it is. And that hopefully on an automated way, right? Um, this is with VMware and to OpenStack not possible because the two environments or the two architectures of these virtualization infrastructure layers are quite different. Also, the concept is quite different. We are talking a bit later about that. So therefore, today we are focusing on replatforming, so a lift and reshape. um, this particular scenario tries actually as well to do a one-to-one copy, but it's a bit more because you have to adjust things which are maybe not available on the source side and on the target side, which is required on the target side, and so on and so forth. The last path is the refactoring. Refactoring today will be most likely for applications or workloads who are business critical, right? So when you know that your application is business critical in any case, and it runs already since years or decades, it's also possible for sure. You should definitely think about to refactor it. It takes time. It costs money because time is money for sure, and but at the end you will get a huge benefit from it because the resiliency and also to distribute your workload properly is most likely better than stop your business if something fails catastrophically. So as I already mentioned, to migrate a bunch of workloads, and I'm not talking about, I don't know, 10 virtual machines. I'm talking about thousands of virtual machines from VMware to OpenStack, actually from a source to a target environment. This process actually doesn't matter if it's now VMware to OpenStack or OpenStack to OpenStack, but you need to define a process for it. From our experience, it shows that we split it off in actually two big phases, which is a workshop and then the actual platform engineering phase. Um, the workshop I will go a bit more in deep for the several points here, but the workshop actually is split it off into parts: discovery and planning, right? And platform engineering is split off in analysis, design, migration, and validation. Again, in the next couple of slides, I will describe a bit more in detail what the different phases means and a step means. But I would like also to highlight that, especially the migration and validation phase, because there, that is, well, as the name says, migration. That's the actual migration, right? And this at starting with this step, it's completely fully automated, or it has to be actually, because otherwise it takes too long, human errors. I mean, the most of you, I think, know all that. So let's take a look to the first two steps. So discovery phase. Discovery and planning is actually for for the customer and also for us as well. So to get an inventory about all workloads who needs to be migrated. Um, During the discovery phase, we actually, before we started the discovery phase together with our customers, we are using tools, auto discovery tool, to gather facts from the source system. This is pretty detailed, which means we are gathering facts about all running virtual machines, about actually the whole utilization and configuration of the cluster. Um, Based on that, we have actually a huge list of well workloads, so virtual machines, grouped into folders and clusters. Um, and we can decide then in the planning phase after that the classification prioritization together with the customer. Um, this is important for sure because prioritization, well, it's up to our customers to decide this because we can simply not know which workload has a higher priority to migrate than another. The classification is actually just to simplify the migration. That means we can classify workloads based on the description from the workload owners, if necessary and if available, right? So for instance, we can classify a tier 3 application or database or whatever. Why? Because then we can adjust the automation pipelines um, for this particular class. Um, at the end, we would like to have after the workshop some informations, right? First of all, a rough estimation. We can provide this per virtual machine or per project. Project is actually a term for an OpenStack. So in this case, it would be a cluster or a folder when we are talking about in VMware terms. And what we also want to have is a workload backlog so that we know actually how many projects or virtual machines we have to migrate. Um, Also, what we encourage to our customers is to provide us at least three test pilots. Um, that means that all adjustments what we are doing later on in the implementation of the automation um, should be tested before, right? And the customer could choose upfront three workloads that we can test. Another thing what I actually missed is to describe is the source destination infrastructure matrix. It's here marked as a deliverable. I just want to highlight this because from my point of view, it's important. Um, when you have a workload who uses services on the source side, you should take care that these kind of services are also available on the target side. For instance, as I already mentioned at the beginning, when you have an external service like a database as a service, email as a service, backup as a service, whatever, right? Um, this particular part should be available on the target side as well. So otherwise, if a workload relies on that, the migration will fail for sure. So that means the validation will fail, and so the application will not run on the target site till this service is available. Analysis and design is actually well, it describes it's based on the outcome from the other phase for sure. um, this is we are stepping in and check the pilots, checking what exactly needs to migrate, and what needs to be adjusted in the migration model. This migration model, we have already template for sure, what is already proved and tested with several customers. And this can be tweaked based on the needs of a workload or based on the needs of the provider itself. For sure, here will be important to know if there is a migration order. For instance, when you have a tier 3 application and you have, for instance, let's say, I don't know, 4 or 5 virtual machines, and on 2 or 3 virtual machines there is a database running on, then you have for sure first to migrate the database, spawn it up, and then migrate the rest, right? Because if the virtual machine of the workload itself, so of the application, of the web server where the application is running on, um, needs to connect to a database, and this database needs already be there. So there needs to be a definition of a order. The design is just to implement by our engineers based on the agreements, based on the requirements from the customers, also from the workload, the missing steps. This can actually also be um, using external services, like for instance, if you have a company wide monitoring system who monitors your workload, your application constantly, and we defined a migration window with together with the customer, we can actually disable this easily automatically via the pipeline. So this is just an example to adjustment of the model. Okay, the migration itself. We have two possibilities here. Actually, the workload owner could migrate their workload by their own. That would be, well, a sufficient migration, right? Or it will be led by us. Both is possible. I frankly speaking, I have not seen yet that a customer really says I really want to do it by myself, because at the end you will not save time or money. Because as I said, it is complicated. Also, you need to take into account that if something fails within the migration or with the infrastructure, you need to have experience to solve that, right? But these two phases, what I would like to say is these two phases are for sure fully automated. Otherwise, there is no possibility around that. The migration itself can be increased in terms of the we can start parallel migrations, parallelism of migrations on several levels. On virtual machine level, so that we are migrating a single project or folder um, directly, I don't know, let's say 5 virtual machines in a batch, or we can also migrate multiple folders or projects in parallel. The validation at the end, I want to highlight this, is how shall I say, is just rudimentary, right? So we will check the availability of the virtual machine, if the network works, and that's it. Because it comes back to the every workload is unique. We cannot test every workload, because that is only possible with the workload owner, because only the workload owner and his team knows their workload and knows what to test, right? So this is up to the workload owner. Um, and usually the coordination will be done by a coordinator who is delivering the message to the workload owner that the all the entities are migrated and the validation our migration was done. After that, the workload owner checks their workload on the target side and agrees, okay, it's fine or not. If not, then we have to check what happened. So the migration relies heavily on actually three major parts: the workload itself, the provider, and the infrastructure. The workload for sure on the design. Well, I think I don't need to say if a workload runs on 40, 50 different virtual machines with a strict booting order. It's it's much well, it's heavier to migrate than a workload who runs on a single virtual machine, right? And as I already mentioned, automation is every time good to have in place. If not, then well, our tool has to fulfill this gap. Um, then the deployment strategy. So if for instance, if a workload already have automation in place and have a deployment strategy like green blue or canary deployments, makes the things also for sure easier, because um, especially the switch from the old production to new production could be easier in this case, because you can switch back. Um, then the migration window. Um, this means we are defining a migration window, and this heavily relies on, well, how this workload operates, in which time zone, where are peak or when are peaks, and so on and so forth. Um, Now, speaking more in the provider view, um, well, the migration and the duration of the whole migration process relies for sure of the amount of workloads. I mean, that's a normal factor. But also on the persistent data. So for instance, if you have 4K virtual machines and just, I don't know, let's say some 20 terabyte of data, it's different from the time perspective than you have petabyte of data, for sure, right? Because at the end, limiting factors, and this is also part of the infrastructure box here, is for sure throughput of network. And also storage performance. These two are the most limiting factors what you have during a migration. For sure, it is a difference if your source and target environment are in the same data center, because then most likely your connection between the environments, so the north-south bridge actually, in both environments are typically fast enough, right? But when it comes to a larger distance of data centers, this becomes more tricky, right? Then the service dependencies, I already talked about that. This definitely needs taken into account. And in the infrastructure box, actually, I already mentioned that the most important is network throughput and the storage performance. Storage performance actually is also critical on the OpenStack side, but I need to say we in Mirantis are using Ceph, which is a highly scalable and highly distributed storage. Um, and it depends what you have on the source side, right? If it's our huge storage tiers, which can be efficient, but from my experience, it depends, right? It really depends also on the disk what you have in, and how fast the read and write at the end is, right? So let's talk a bit about the actual migration type with Lift and Reshape. As I already mentioned when I showed you this picture of the three different paths, um, I mentioned already it's a kind of one-to-one copy, right? Or let's say we try to do a one-to-one copy. It's not fully possible because these are entirely different environments. So what we have to do here is driver manipulation. And I want to highlight this. Um, this is unusual because usually we have a strong message, and this is we are not touching any workload. This is super important because we cannot go to a customer and say, well, it could be happen that we need to change your code or your configuration of the system, because then you can run in huge discussions with this customer when something fails at the end with the migration, right? Because then you have to prove that's not your changes what happened. But in this case, we have to. Otherwise, it will not work. In VMware, we have to well, remove VMware drivers inside a virtual machine and interact actually the VirtIO drivers to run on top of KVM. This is the only thing what we have to do and what we will do. This is possible for several operating systems. Another thing is the entity mapping. In For instance, I just can give you a quick example. In VMware, for instance, there is no entity, and I'm really speaking about the entity in VMware when you call the API, for instance. There is no entity in regards to images or projects or flavors or SSH keys. They are for sure networks, but the networks are, well, it depends for sure what you're using, how your VMware system is designed. But you have to map that, right? All these entities you have to map somehow. And we need, for instance, in OpenStack a flavor, right? A flavor is a description of the resources of your virtual machine. So memory, CPU, and the disk itself. This is also possible, and the information are all there, right? So that's not a problem, because in VMware you can actually just configure these um, based on your needs, right? But in OpenStack you get a flavor, which is a predefined not box, but resources for your virtual machine, right? And we have to map this somehow. And the same is for projects and images. And this is a bit more complicated because that means you have really to think about how you can leverage these both different concepts of environments and in a virtualized infrastructure. The migration itself will be a cold migration, at least till now. Live migration is not yet possible. We will guarantee a secured access and connection, or well, as much as possible for sure, secure access and connection between the environments. This is it depends here if typically it is for sure, but this depends for sure how the networks in between looks like, and also how the VMware side is configured. On the OpenStack side, we are using for every connection is encrypted, and therefore we rely here more on customer side. The source will be deleted after successful testing by owner. That means this is okay. It's actually a compromise or agreement with the customer how he would like to handle it. Some of our customers just want to have the source still on the source system, just as a old backup or so. But typically, the most of our customers are trying to cleaning up the system just to save money, right? And which is for sure a viable way to do that. So after a workload owner validates successfully their application and goes back to this coordinator and say, yep, my application is up and running like expected, then we are going to clean up the source system. So let's talk about some challenges what we encountered during our challenge. So the first of all, we are exporting OVF container, right? That means we are taking the OVF container from vCenter, which actually pass through directly to the ESXi host, and download it to a worker virtual machine directly running in the tenant, so in the target tenant, which will be spawned up by automation pipeline. That means, and that's actually directly the another point here, that means we need temporary additional disk space. I will come later to that. This OVF container contains the root disks, the root disk, and if available, additional whatever data disks, or I don't know what the customer is using, but all disks are available in this OVF container format. Our tool is scanning for that for the root disk, and also it creates directly an appropriate volume for it. So it scans the disk, the size of the disks, and then creates on the OpenStack side a Cinder volume. This is, well, actually entirely different concept how OpenStack typically works, because in OpenStack you're using base images to spawn up virtual machines, and then configure and install all your stuff. And all this is ephemeral, right? So if you terminate your virtual machine, it's gone. But with a volume, it's persistent. We have to do it on that way because on VMware side, this concept doesn't exist simplified. And we don't want to upload large disk images as a base image, which is not true. Therefore, we are using a volume, a bootable volume, and copy all the stuff into this volume. And this brings me directly to the right box on the bottom, the temporary additional space, the disk space, because that's something what currently still needs to be done. We're working on that to improve this. That means that the disk images are living for the time of the copy process on this virtual machine. It will be for sure deleted, right? But at this time, you have all the disks are temporarily saved there. The good thing is, on the other hand, we are copying to the Cinder volume and trim all the zeros out. So it will, when you have a disk with 20 gigabytes and you just use inside a disk 200 megabytes, for instance, we just copy the 200 megabytes to the volume. So it will at the end also save on the target side a bit storage, right? But again, at the end, we have a temporary additional disk space what we require. We are using lib guest fs tools, right? To inject and remove the drivers from inside of virtual machines. It's it's a well-known process actually. We are manipulating the inner drum fs and then during the first boot. Therefore, we require kvm as well. During the first boot of the virtual machine, inner run fs will execute some scripts, and just as a one-time runner, and just removes and installs the drivers, and that's it, and removes itself. And I already spoke about the different infrastructure concepts, what you see on the left side. Today, we will not use SSH keys to provision a virtual machine on the target side, which is actually necessary in the OpenStack world. Otherwise, you cannot you cannot access your virtual machine. But usually these is actually all configured already, right? From the VMware side, we are taking this base image, which is already configured with all the keys, with all the access. Who knows, or we hope at least, and we just copy it over. And well, in summary, how do we mitigate these challenges? As I already mentioned, some of them we are still working on that, especially for the temporary disk image. This is not easy to solve. The other ones is well, we put automation on it, right? This reduces a lot of effort at the end, for sure. At the beginning, not. That is something what many people are looks like not understanding, that automation at the beginning, or to implement automation at the beginning, takes time, but at the end it will save time. So it reduced the effort. It reduced human errors. Um, and it will reduce also, well, somehow the time of living of the temporary occupied storage, because if you have to do it manually, all this stuff, you have to clean up as well manually. And when you think about, you have 10, 20, 30 in parallel migrations, and you have some people sitting there who will execute and cleaning all this up. The time in between, I mean, the time in between of finishing migration and cleaning up job will be definitely larger than if you have automation in place. And automation improves the mapping of the entities for sure. The validation is also go through a QA, right? It's actually it contains two parts. It's out, as I already mentioned, it's automation. We have QA engineers who maintain these pipelines. There are several scripts in there described um, for to check actually all the standards, right? So FIPS and CIFs and stuff like that. And the last part is a detailed planning and tight communication with the customer. This is absolutely necessary, because in every migration project, there will be some challenges and difficulties, especially when it comes to workload owners who are using the system not on the way how it should be used, right? And then you need to have a strong communication with your direct coordinator and partners. Okay, questions so far?
Right. Yeah, so thanks, Heiko. Some great information there. So yeah, I think we have time for just maybe a couple of questions. Let me look here in the in the question chat here for the presenters, and I think two that look pretty interesting that to get your thoughts on. The first being, how do you go about estimating a migration?
Yes. So the estimation is for sure not fully exact. That cannot be, never be. If someone tells you have an exact estimation, he definitely will lie, because every single source system is usually or typically in use, right? And that means that the workloads using it have spikes, have different time slots where they use or utilize the system more or less. That means especially the two main limiting factors are affected storage and network, right? So estimation, how we are doing this, I described during the first at the beginning the different phases, and during the discovery phase and the planning phase, um, we have a tool who are gathering facts. I already mentioned that. It will create a spreadsheet fully automatically with several parameters in regards to throughput, in regards to gigabyte or expected gigabyte transfer per week and something like that. So also IO ops in the storage. Based on all this information, the tool actually calculate or do a rough estimation for per virtual machine and per project or tenant or folder or class, however you would like to group it. But that's it, yes.
Okay, well, thanks. And the other one, and maybe just briefly, um, you mentioned earlier talking about migration of sort of doing a cold or offline migration, and that currently that live migrations are not possible. Can you just comment maybe quickly on why that's the case, and do you see that changing over time?
Yeah. So, okay. First of all, a live migration is very hard to achieve, because a live migration means you have to create, first of all, a mirror of the data. So the data needs to be replicated, and data means all data. So that means that the source system and the storage must be able to do that, um, because we have to actually to mirror the whole disk, right? The second thing is, if you have successfully solved this challenge, let's put it that way, which is actually again possible with some vendors and storage vendors. If you have successfully solved this one, then you also have to think about when you switch. Um, at the point when you switch, you have to migrate the whole memory to the target environment. This is in a closed environment. Let's from in VMware, for instance, right? From one compute node to another. Actually, not a big deal. Also, in OpenStack, not. It's the same capability. But if you are doing this over environment, so from VMware to OpenStack, this is an entirely different story, and that makes the thing super complicated. And therefore, we currently rely on a cold migration, because the the memory and all the cache of the what you write usually to the disk needs to be flushed to the disk before we migrate. Therefore, we need currently a cold migration.
All right, great. Well, thanks. A lot of good insight in on the complexities involved with the migration activity, but also the fact that it's certainly something that is very achievable and able to be done when broken down into to the right steps and the right planning involved in that. Um, All right, so I want to wrap up here today, just to highlight for our audience that if you are looking at migration of your virtualization environment away from VMware towards OpenStack, Mirantis certainly is there and it's able to help you. We offer a workload migration service through our professional services team that can really deliver two things to you. First is helping you put together a seamless migration strategy to really plan out that transition path. And then that's something that either you can kind of take from yourself or certainly continue to work with our team of experts who have many years of expertise in OpenStack and migration of workloads to help drive and automate and implement that migration for you. And it's certain something that Heiko and others on the team would be more than happy to explore and dig in deeper with you on your particular applications. And at a broader level, Mirantis can help you in many aspects of your virtualization infrastructure and or cloud native journeys. We offer a variety of product offerings: the Mirantis OpenStack for Kubernetes that we just discussed earlier, Mirantis Container Cloud for helping to manage the visibility and management and ongoing maintenance of your infrastructure, and then tools like Stacklight and Lens that can really help provide you with a high level of visibility into your infrastructure for the ongoing monitoring and maintenance. We have couple that with support offerings, whether that be our OpsCare offering, which is a 24 by 7 offering to provide support, self-care support, if you will, for customers that wish to address issues themselves. Or we also offer a fully managed offering if you would like Mirantis to help take on the management of your infrastructure and provide that support level for you so that you can put your valuable IT resources onto things such as application development and refactoring applications or moving things forward for your business. And that's certainly where our professional services team comes in. As we've been discussing throughout today, the ability to provide end-to-end application services and things like the workload migration and refactoring that we've discussed. And then finally, kind of cap that off with training, whether that be product-centric training, but also just general technology training around OpenStack and Kubernetes. If you're early in your cloud native journey or learning about OpenStack or learning about Kubernetes, Mirantis can certainly help provide you a very strong kickstart to move you forward at a rapid pace there. So with that, we want to say thank you for your time today and joining us on this important topic. If you have any further questions, we'd be glad to take those offline, or you can reach out to us at www.mirantis.com and both learn a lot more about our products and offerings there, or certainly reach out to our team to have a one-on-one conversation and address your particular needs. So with that, we'll say thank you. Have a great day, and we'll look forward to you in a future webinar. Thank you.
Thank you, guys.